this is on CIFAR10 dataset. So this is like the collection of the image in which we are going to create a model and train the model so that it will do the classification on the image. So first we are going to import all the important libraries here. So in the CIFAR10 dataset we have around 60,000 image, and they are very small, like they are only 32 into 32, and they all are RGB image, so we'll have a 3 dimension. And here we are loading the data like the X train, Y train, and X test and of the Y test. Then we are checking the size of the train data and the test data. So in the first value in this tuple is 50,000, so the number of image into the train data we have a 50,000, and the image has a size of 32 into 32 pixel, and 3 is telling like it's the RGB, so we have a 3 dimension for each pixels into R, G and B. So then we are checking on the Y train and Y test. So for the Y train we have 50,000, the same as the X train, and Y test we have a 10,000 columns. So basically we have seen, like, if you'll see here the total class we have um, the num class. So total unique value in Y we have from 1 to 10, so we have total class as 10. So we have given a name here so that we can print it later on, but it will not be used for modeling the data. In the modeling the data we'll use only the integer part. So here this is the uh, class name: airplane, automobile, bird, cat, deer, dog, frog, horse, sheep and truck. So total class we have is 10. So here I'm plotting each the first image of from the each class. So image are too small, that's why it's coming as in a distorted order. So here we can see horse, here it's the automobile. So from the same dataset we are going to train the model after creating it. So in the pixel value which we have, it will vary from 0 to 255. So to normalize the pixel value so that we will get the little bit more accurate model, and it will be easy to uh, calculate the parameters into the model. We divide it by 255 to from each pixel value. So we'll change the type of the, because in the pixel we have an integer type, so we'll change it to the float 32, and then we can divide by 255.0. So the value which is having the 255, now it will be have value 1. So all the pixel value will be vary will exist between the 0 and 1. So this is the normalization we have done on the pixel value. Then we are doing the hot uh, encode outputs on the output data. So this is nothing but a binary value. It will create a matrix of 10 row, and whatever all value will be 0 except the one value for which this y value represents 2. Then here we are creating the model in which we have taken the convolution um, model. So we have taken the 3 convolution model in which we are padding with the same, and activation we have activation function we have taken as a ReLU, and first fill for the first convolution layer we have given the 32 filters, then 64 and a 64, and then we are doing the max pooling after each convolution layer. Then we are putting the dropout as a 20%, so it will drop the field uh, drop the value by 20%, and it will take only taking forward it will take only the 80% of the characteristic. Then we are doing the flattening and we are creating a dense layer of 256 uh, value, and the activation is RELU, and at the last we are creating the dense, like out of 256 we are taking only the number of classes, because at the end we have to predict out of 10 class. So here the number of classes is 10 here, so and this is the soft max. Then here we are compiling the model. For the compilation of the model, the loss should be the categorical cross entropy, because we have done the hot encoding for the y. So in that case, mostly we use the categorical cross entropy. And for the matrix, like for the plotting and all, we have taken the, for the matrix of, to get the matrix of the model, we have taken the matrix as accuracy here. And this is the model summary. So total we have 32 321290 parameters into this model to, so that we can train them. And this is the train the model. So here if we are training the model, so I have put the seed as a 21, so it will do the random seeding, and epoch as a 10 and batch size as a 32. So here this is the entry for the X train and the Y train, and here is the validation data we are doing for the X test and the Y test. So if we can see here the accuracy is increasing. This is on the training data, this is loss on the training data, this is the validation on the, this is the loss on the validation data, and this is the accuracy on the validation data. So to visualize the results, we can do the mapping on the history, on the accuracy and val accuracy loss, and the val loss parameters. So this is our final pictorial figure of our model after fitting. So we can see the training accuracy is increasing as per our epoch, and also the validation is also increasing, and it's going to be a constant somewhere between the like 0.70 to 75, near to 75% accuracy you can say in this model, and the loss is decreasing in both case for the training data and the validation data. So from the accuracy we can say like it's not overfitting, it could be a little bit overfitting here, like as we are going ahead. Then what I have done, like I have taken 5 different images from the internet. We can show all the image. This is second, this is third, this is third image, this is fourth one, and this is the fifth one. And I have check the model how accurate it is and how it's performing. So first one is for the horse, second one is for car, third one is for dog, fourth one is for plane, and fifth one is for sheep. So horse, car, dog, plane, and sheep. So this is, I have made the entry into the dictionary so that we can iterate over the this, and we can plot it on the, and we can see the prediction of the each image. So after running it, and actually we have, I have uh, given the size to 32 less, so I've resized all the image on 32 to 32, because for the model we have given the input as a 32 by 32 a pixel, a 32 by 32 image. So I have resized all the image to 32 and 32. Then we have given that one input into our the model. Here it's predicting the, and we'll get the prediction, and we are taking the soft max, like the maximum value for which out of 10, for which class it's giving the maximum value, so that will be our score. And then we are printing the image and also the what is its prediction. So for the horse it's showing as horse, that's good. For the automobile it's showing the automobile, for dog it's dog, for airplane it's showing the aeroplane, and for ship it's showing ship. So this is our final model which we have created on the dataset CIF AR10. Thank you.